All right, we're into the first like substitution and solving ones. Here we go. Okay, I'm going to treat sine like it's a y and cosine like it's an x. If you guys had a function like this, 2y squared plus 3x minus 3, you would not be able to solve this. In fact, you guys were taught way back in the day that if you had a function like this, the only way to solve this is to have a system of equations. So you would have to have two equations to solve an equation that has two variables.
Yeah, how do we do those?
How do you do that?
They're on like the eggs.
I know, right? It's like, what the heck? Well, here, check this out. You guys know cool tricks with trig functions. We don't have this. We have this. And you guys know substitution for this guy. That would be cosine. Is there a substitution for sine squared x that would give you a cosine? Yeah, Fulio Mulios. What would I take this out for and put in? 1 minus cosine squared x. That's right. Okay, now hopefully you're seeing where I'm going with this dude. Yes? No? Yes? Yes. All right, check this out. So I'm going to distribute this 2 right here, and I'm going to get 2 minus 2 cosine squared x plus 3 cosine. So I'm just writing out the rest of it. I don't need to read it all. And then I'm going to combine like terms, positive 2 and negative 3. Those I'm going to combine those. So I'm going to have negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. Now I have something way prettier. I have something that looks like this. Negative 2x squared plus 3x minus 1. And I'm just writing it like this so you guys can clearly see how to factor this. Some of you guys don't need to do this, but some of you guys do, so I'm doing it. All right, so I'm going to use the box to factor this. I put negative 2x squared in right there and negative 1 right there. I'm supposed to add these two together to get 3x. And so your question is, negative 2 times 1, negative 1 is positive 3. So what multiplies to give me positive 3? Is that right? No. I know how to multiply. Negative 2 times negative 1 is positive 2. What multiplies to give me positive 2 but adds to give me positive 3?
2 and 1.
2x and 1x, right? 2 times 1 gives me 2. And then 1 plus 2 gives me 3. Okay, so we keep going with this. What can I divide both of those terms by? And you would say 2x. What can I divide both of those terms by? You would say nothing. Just put a 1 right there. And then what can I divide both of those terms by? What can I divide both of those terms by? X. What can I divide both of those terms by? 1. Okay, now we have a problem. Do you guys see the problem?
Yes.
Because 2x times x does not give me negative 2x squared. But 2x times 1 does give me positive 2x. And look, 1 times 1 does not give me negative 1. Okay, what can I change here to fix this?
You put negative 1 there.
Negative on the 2 and a negative on the x. Yeah. There is another way to do this, but that's the way I saw it right away. I think the other way is to switch negatives. Like you could put a negative on this one and this one, I think. Does that work? Yeah, that works too. Okay, so you can pick whatever you want the negatives to be on. It's the same no matter what. All right, so now I have negative 2x plus 1 and then x minus 1. So I'm coming back to my trig equation. I'm going to say negative 2 cosine x plus 1 and cosine x minus 1. This equals 0. So I just took the x's out right here, and I put my cosines back in. So now I have my factored form of that equation. Now I take each of those guys, set them equal to 0. And then I get busy with it. What does that mean? Okay, cosine x equals negative 1/2. Because I have to subtract 1, then divide by negative 2. And then I get cosine x equals 1. All right, let's think about our unit circle here. Where on this unit circle does cosine equal? No, that's supposed to be positive, not negative. Sorry. Okay, because when you subtract 1, it'd be a negative 1. Then you divide by negative 2, so it'd be positive 1/2. Where is cosine x equal to positive 1/2? I know in quadrant 1 and in quadrant 2 we get positive 1/2 right here and right here. Isn't that right? 1/2 is right there in the middle. And then, okay, so what is the angle for this one? Huh? Okay, so I get pi over 3. And then, what's my other one? 5 pi over 3. So if I go all the way around to here, that would be 5 pi over 3. Do I have to do the plus period thing?
Yeah.
Do I have to go because I have to add the period to get all the answers? Do I? Yeah, I do. Okay, so I have to add the period to this also. Now what this means right here, when I add 2 pi to it, that's just saying okay, if pi over 3 gets me right here, I can go all the way around plus pi over 3 to get there again. Or I can go all the way around plus, to get there again. So I'm just saying I can add 2 pi multiple times or even subtract 2 pi multiple times to get to the same coordinates. Question, go ahead. That was a good question. Your question was, can you write, instead of 5 pi over 3, can you write negative pi over 3? That would be the same thing. Because this is adding 2 pi. Well, you can make n into a negative 1, so then you'd be subtracting 2 pi. You get the same thing you just said. So good job. Next, we got this guy. What can I plug in the cosine that will give me uno? Do you know? Right here. What are the degrees for that? Yeah, x equals 1 right here. So we say 0 degrees for that. Oh wait, not 0 degrees, 0 radians. And or what? How many radians could you say? 2 pi. Or what can you say? 4 pi. Or you guys see it? It just keeps going. So I gotta say x equals 0 plus 2 pi n, but more simply put, just 2 pi n. So here are your answers. There's 3 of them. Oh, man. Oh, wow, that's a horrible box. Let's kind of make that just a little bit better. Okay, that's good. Those are your answers.